तेजस्विनावधीतमस्तु मा विद्विषावहै। ॐ शान्ति शान्ति शान्तिः।
Welcome back to Prestressed Concrete Structures. This is the fourth lecture of the Module 1, Introduction, Prestressing Systems and Material Properties. In this lecture, we shall cover post-tensioning, and under it we shall cover the introduction, the stages of post-tensioning, advantages and disadvantages of post-tensioning, the devices used. Then we shall focus on the anchoring devices, the sequence of anchoring, jacks, couplers and grouting. As we had mentioned earlier, that the prestressing can be broadly classified into two types. One is pre-tensioning and the other is post-tensioning. The post-tensioning is the one where the tension is applied to the tendons after hardening of the concrete. This is different from pre-tensioning. In the pre-tensioning, the tension is applied first and then the concrete is cast. In our last lecture, we covered pre-tensioning in details. In this lecture, we shall cover the post-tensioning and its devices. In post-tensioning systems, the tendons are placed in ducts after the casting of concrete. The duct prevents the bond between concrete and the tendons during the tensioning operation. Now, this is very essential because when the tensioning operation is done, if there is resistance, then the tension will not be applied properly. The duct ensures that there is no bond between the concrete and the steel during the tensioning process. Now, unlike pre-tensioning, the tendons are pulled with the reaction acting against the hardened concrete. In the last lecture, we mentioned that in pre-tensioning, the jacks need an end abutment to get the reaction, but in post-tensioning, we do not need such an abutment because the jacks are placed against the concrete member itself, from which it gets the reaction. Now, after the tensioning operation, if the ducts are grouted, then it is known as bonded post-tensioning. Grout is a neat cement paste or a sand cement mortar containing suitable admixtures. Now, the grouting is done to prevent the steel tendons from corrosion, and after the grouting there is a contact between the concrete and the steel through the hardened grout. Now, in unbonded post-tensioning, as the name suggests, the ducts are never grouted and the tendon is held in tension solely by the end anchorages. The purpose of unbonded post-tensioning is that it avoids the process of grouting, and it is usually used for slabs where grouting may be difficult in the small duct holes. But in most of the cases where corrosion is a problem, the tendons are always grouted, and hence it is a bonded tendon. Now, this sketch gives a schematic idea of the post-tensioning operation. The duct can be a curved form based on the design of the profile of the tendon, the tendons are attached in one end by some anchorage system, and then on the other side the tendons are pulled by the jacks. Now, once the tensioning operation is done, then the grout is pumped from one end, and as the grout flows, it is made sure that it covers the full length of the duct, and so that the excess amount of the grout oozes out from the other end. There are some vent tubes for the escape of the air, and there are some drain tubes for the escape of the excess amount of water. Now, the grouting process is a very important process for a bonded post-tensioning system, because if it is not grouted properly, then the assumption in the analysis that there will be a stress transfer in the interface of the concrete and the steel will not be valid if it is not grouted properly. In this photograph, you can see that the ducts have been laid within the reinforcement cage. There can be several ducts depending on the size and the load carried by the member. Now, these ducts are usually made of some plastic or PVC sheets, and these ducts need to be clean. The annular space within the duct has to be free of any debris, so that when the tendon is passed through the duct, there should not be any obstruction. Now, in this photograph, you can see that the end portion of the post-tensioning system has been cast previously by a high strength concrete, because most of the stresses are concentrated in this end region, and that is why the end region is subjected to higher stresses as compared to any other portion of the beam. This is a box girder section of a bridge deck. A similar section, after it has been post tensioned, you can observe that the tendons are sticking out from the end blocks, and once the full post tensioning operation is done in one duct, then the excess amount of the tendons are cut off, and this end anchorage block may be covered with grout, so that it is not subjected to corrosion. The various stages of the post tensioning operation can be summarized as follows. First, the concrete is cast. It is allowed to cure and harden to achieve the desired strength before the tensioning operation is done. Next, the tendon is placed in the ducts which were located within the concrete, and after that the anchorage block and the jacks are placed at the ends of the members. Next, tension is applied to the tendons, and the wedges in the anchorage blocks are allowed to sit so that the tensions do not slip from the anchorage blocks, and finally the excess amount of the tendons are cut off from the ends. In this first sketch, we can see when the concrete is cast, there is a hole or a duct inside the concrete. Again, this duct should be free from any debris or obstruction, because later on we are going to pass the tendon through this duct. In the next stage, the duct has been passed through the tendon has been passed through the duct, and it has been anchored in one end. A jack has been placed on the other end, and the jack is applying tension to the tendon. Now, as the tension is applied against the concrete will undergo elastic shortening. Now, this is different from the process of pre-tensioning. In the pre-tensioning, since the jacks get the reaction from the end abutments, the elastic shortening does not occur during the tensioning period, because at that time the concrete is not there at all. The elastic shortening occurs when the tendons are cut and the prestress is transferred from the steel to the concrete. But in the post-tensioning operation, the elastic shortening occurs when during the jacking operation itself. Hence, when the final jack force is recorded, by that time the elastic shortening has already occurred and it may not be considered as a loss in the prestressing force. We shall discuss this again in details when we study the losses of prestress in the second module. Now, as I said before, that in the pre-tensioning system, if we use a precasting bed and an end abutments, it needs strong foundations. We can avoid a strong foundations if we use a stress bench, which is a self-equilibrating system. Now, in post-tensioning, the whole process itself is self-equilibrating, because the jacks get the reaction from the concrete member, and once the tendon is anchored at one end, the whole system, the prestressed member itself, is a self-equilibrating system, because the tension in the steel and the compression in the concrete, they balance each other. Thus, in post-tensioning, we do not need any special foundation during the tensioning process. Now, this figure will show the difference between a bonded tendon and unbonded tendon. Now, in this sketch, you can see that the duct hole is free of any grout. You can see this black annular space which does not have any grout. If the beam is left just like this, then it is called an unbonded post-tensioned beam. But if the annular space is filled up with a grout, then it is called a bonded post-tension beam. Let me show this once again. In this beam, the annular space between the tendon and the concrete is free of any grout, and there is no direct stress transfer between the steel and the concrete along its length. The prestress is transferred only at the end anchorages. But next, if we fill the space with grout, after the grout hardens, then the steel and the concrete are bonded together, and then there can be stress transfer between the steel and the concrete. The prestress is transferred by the end anchors as well as along the length of the prestressing steel. Now, for a bonded tendons, there is a strain compatibility between the prestressing steel and the concrete. What it means is that the change in strain in the prestressing steel at a certain location is same as the strain in the concrete at that level. This concept we shall be studying in the module of analysis of beams under flexure. The stages of prestressing by the post-tensioning method is explained by this animation. First, we need a casting bed where the concrete will be cast. After placing the molds, the concrete is cast with the duct inside it. Now, the duct leaves a space within the concrete which should be free of any obstruction. After the concrete cures and hardens, a tendon is placed through the duct and then one end is anchored. Here you can see that the left end has been anchored, and in the right end we have placed a jack which gets the reaction from the concrete itself, from the hardened concrete. Now, once these are placed in position, the tension is applied by the jack, and you can see as the jack applies tension, the concrete undergoes the elastic shortening. And next, okay, before I go to the next one, let me show the previous animation once again. See, as I said, in the post tensioning, the casting bed need not be like a pre-stressing bed in the pre-tensioning system. The casting bed is just like any other ordinary casting yard, and after the mold is placed, the concrete is cast with a annular space inside. This space is provided by placing a duct inside the concrete, and after the casting of the concrete, after it has cured and hardened, a tendon is placed within the duct, and then the end anchorage is placed at one end. On the other end, a jack is placed which gets reaction from the hardened concrete itself. When the jack applies tension to the tendon, the concrete member undergoes elastic shortening, and the tendon is subjected to the desired amount of tension, and then the jack can help the wedges to sit against the concrete member, and then the extra amount of the tendons is cut off from the two ends. Next, we shall see the same operation for a post tension beam with a curved tendon. Now, the curvature of a tendon is designed based on the moment the member will be subjected to in its service period. Now, the curved profile is fixed by placing the duct appropriately with hangers within the reinforcement cage of the pre-stressing member. Now, in the casting bed, after placing the mold, the concrete is cast with a curved duct inside it. Here you can see that the profile of the duct is curved, and which should be free of any obstacle. And once the concrete has cured and hardened, the tendon is passed through the duct, and the profile of the tendon becomes similar as the profile of the curved duct. Next, we place the anchorages at one end and the jack in the other end. The jack gets the reaction from the hardened concrete, and when it is applying the tension, since the tendon is curved, it will have an upward displacement which is called cambering of a post tension member, and due to the cambering, the member will hog up from the casting bed. Now, once the jacking operation is done, the extra amount of the tendons is cut off from the two ends. Now, the post tensioning operation has some advantages as compared to the pre-tensioning operation. First of all, the post tensioning operation is suitable for heavy cast in place members. In my earlier lecture, I had mentioned that the pre-tensioning operation is suitable when the members are produced in bulk, like say electric poles, railway sleepers, and when those members are relatively lighter than the bridge decks, which are usually post tensioned. If a bridge deck is heavy, then it can be cast in place and the post tensioning operation is done at the site where the deck will be there, or else if there are provisions for shifting the bridge deck from the casting yard to its final location, then the member can be precast in a yard. It can be post tensioned after the member has hardened, and then it can be shifted from the precasting yard to its final location. Next, compared to pre-tensioning, the post tensioning has a less waiting period in the casting bed. I mentioned earlier that for pre-tensioning, the pre-stressing bed is occupied by the concrete member till it attains the required amount of strength before the transfer of pre-stress. Now, this can be a hurdle when there is a high demand for the pre-stressed members, but in post-tensioned case, once the concrete is cast, the mold can be shifted, or the casting bed may not be required for casting as the subsequent member, and hence it does not create any hindrance in the production of the post-tension members. Usually the production of post-tension members is low as compared to the production of pre-tension members. Another important advantage of post-tensioning as compared to pre-tensioning is that the transfer of pre-stress is independent of the transmission length. Last time I mentioned that in the pre-tensioning operation, in the pre-tension members, the transfer of pre-stress occurs along its length, especially towards the end, which is called a transmission length or a transfer length. Now, the bond between the steel and the concrete has to be good to transfer the pre-stress from the steel to the concrete in a pre-tension member. Whereas, in a post-tension member, the transfer of pre-stress is not dependent solely on the bond between the steel and the concrete. It is the anchorage blocks at the end which transfers most of the pre-stress from the steel to the concrete. Now, there are some disadvantages of post-tensioning as compared to pre-tensioning. In the post-tensioning operation, we need much more developed anchorage device as compared to pre-tensioning. In pre-tensioning, the anchorage devices are small. They are usually these are actually just some chuck assemblies for the individual strands, but in the post-tensioning operation, we shall see that we shall use heavy duty anchorage blocks for the transfer of pre-stress from the steel to the concrete. Now, transporting this anchorage device and the supply may be a hindrance for a project which is in a remote area. And the second disadvantage is that for a grouted post-tension beam, the grouting equipment itself has to be transferred to the location where the tensioning operation is done. If the post-tensioning is done at site and if the site is remote, then transporting the grouting equipment is another necessary task for the post-tensioning operation. Next, we shall move on to the devices that are used for post-tensioning. Just to recollect, in the pre-tensioning, we had seen that the main devices were a pre-stressing bed, the end abutments with appropriate foundations, then we needed some jacks, and then we had to have some cutters for the tendons, and if we avoid a pre-stressing bed with end abutments, then we need some sort of stress bench which is a self-equilibrating system. Now, in the post-tensioning, we do not need a sophisticated stress bench or a pre-stressing bed. We just need a simple casting bed and the shuttering can be placed on the casting bed itself, but we need some additional ducts because we have to place the tendon after the hardening of the concrete. We also need anchorage devices which are more complicated than what we have seen for the pre-tensioned case. We need jacks just like as we use jacks in the pre-tensioning operation. Usually the jacks used for post-tensioning operations are even larger because post-tensioning operation is done for larger members. We may need also couplers. The couplers are devices which joins two prestressing strands end to end, and we may also need the grouting equipment if we want to have grouted post-tension beams. Next we shall move on to the anchorage devices for the post-tension beams. This is a very important device for the post-tensioning system because unless it is properly designed, it will not be able to transfer the pre-stress to the concrete. Now the anchorage devices are designed based on the following principles. The first is the wedge action, the second is the direct bearing against the concrete, and the third is the looping of the wears. The first wedge action, let me explain it to you by a sketch. When the wedge is being pulled by the tendon, it gradually sits in this block, and due to the friction action, the wedge is not able to move any further. Hence, that tension in the strands can be maintained by this wedge action, which acts on the principle of friction between these two blocks. Thus, the wedge action produces a frictional grip on the wears. The anchorage device based on wedge action consists of an anchorage block, which is substantially a large block which can hold several wedges at a time, and then it also consists of the several individual wedges within the anchorage block. The strands are held by the wedges in the anchorage block. Now, there are several patented systems of this wedge based anchorage blocks. Some of these systems are the Fresinet, Gifford-Udall, Anderson and Magnell-Batten anchorages. The detailed specifications of these anchorage blocks are available in the catalogs, which provide all the geometric specifications, the load carrying capacities, the material used for the anchorage blocks. This is a simple Fresinet T-system anchorage cone. Here you can see that these wedges will sit inside these blocks during the tensioning operation of the strands. Now, this wedge is for an individual strand of the prestressing tendon. Now, in an anchorage block, there are several strands which can be held in place by the wedges. The anchorage block consists of an anchor head and which rests on a bearing plate. The bearing plate will get the reaction against the concrete. Then there is this conduit in the shape of a trumpet which gets attached to the sheath of the duct. The strands are passed through this sheath and the anchorage block, then they are fixed to this anchor head by the wedges, individual wedges for the strands. In this photograph, you can see the assembled unit of the anchorage block. At the end, we can see the anchor head, which can accommodate several wedges for the strands. There can be a hole in the bearing plate through which the grout can be passed. Then we have the trumpet shaped conduit, finally which is attached to the duct which is placed inside the concrete. The second type of anchorage device is based on direct bearing from rivet or bolt holes or button heads formed at the end of the wires. Again, there are different types of patented system. The BBRV post tensioning system and the Prestressed system are based on this principle of direct bearing of the button heads or the rivets against the concrete. In this case, you can see that the individual wires have a button head which are resting in the anchor head block, and again the anchor head is resting on the bearing plate which rests against the concrete. Now, this does not use the wedge action as shown before. Here the button heads are just bearing against the anchor head, which is bearing against the plate and which is further bearing against the concrete. In the third system, which can be done for small wires, this is based on the principle of looping the wires around the concrete. That means once the wire has been tensioned, they can be looped around the concrete so that it does not move against the concrete. The Bauer-Leonard system, the Leoba system and the Duct single bar anchor system work on this principle. As I said, that this principle can be used only for a single wire or a single bar at a time. The anchorage devices, before they are patented or if they are used for some special situation, they are tested for their strength. The following photo will show the testing of an anchorage device. In this test setup, we can see that there is a reaction frame against which there are some jacks. The jacks are holding another horizontal beam which is holding the strands at one end. The anchorage device has been placed at the top, and as the jack is applying the load, the lower beam is moving downwards and hence it is applying tension in the tendons, and which is transferring the tension to this anchorage block, and like this the anchorage block can be tested for its strength. Now, this type of test can be done not only for the strength but also for the fatigue characteristics. In bridge decks, the loads are usually dynamic in nature and it can fluctuate over many cycles. In order to see the performance of the anchorage device for varying loads, these blocks can be subjected to fatigue testing. Now, the sequence of anchoring is important to have proper anchorage of the strands against the concrete. Now, the following figure will show the sequence of stressing and anchoring the strands. First, when after the strands or tendons are passed through the duct, the wedges are placed in the anchor block. Then a double acting jack is placed against these wedges. Next, another set of anchor block and wedges is placed on the other side of the jack. The jack applies the load which the piston moves out this anchorage block outside. Once the required amount of tension is applied, then the double acting jack applies a push to the anchor block on the left, which helps to seat the wedges inside their sockets, and finally after this operation is done, the extra amount of the tendons are cut and the jack is taken out. This photograph shows an assembled unit of the post-tension anchoring system. Here you can see this is the duct through which the tendon passes. This is the trumpet shaped conduit which is attached to this bearing plate. Now the bearing, against the bearing plate the anchor head rests. There are several wedges, each wedge is holding a strand, and once the tensioning operation is done, once the wedges are sitting properly in the anchorage block, then there can be a capping of the anchorage block which can be done by a cement mortar grout, and this capping is helpful to resist any corrosion in this anchorage block. The proper functioning of the prestressing is very much dependent on checking the corrosion of the prestressing tendons over time. Now during the tensioning operation, the jacks is the most important equipment that we need. As I said that there can be several types of devices to applying the prestressing force. The most common is the hydraulic jacks, which work on the principle of oil pressure. The design of these hydraulic jacks are based on the Pascal's law. This photograph shows some double acting jacks. Now the double acting jack means pistons can move both at the top as well as at the bottom. There are two inlet and outlet for the oil. When oil enters through one side, then the piston moves in one direction, and when the oil moves from the other port, then the piston moves in the other direction. This type of double acting jacks are necessary because in one side we need to push the anchorage blocks to apply tension, whereas on the other side we need to push back the anchorage block and the wedges before we can cut off the prestressing tendons. The double acting jacks are almost essential for this post tensioning operation. The other types of prestressing force devices like mechanical systems or electrochemical systems, and those devices are not suitable for a post tensioning operation. In this figure you can see the assembly of the jack, the anchorage blocks and the other devices for the anchoring of the tendons. The strands pass through this duct, it goes through this trumpet shaped guide, then it passes through the bearing plate, it passes through one anchorage block with a set of wedges, then it passes through the double acting jack, and on the other side of the double acting jack there is another set of anchorage block and wedges. And here we can see that once the piston moves in one direction, the tension is applied. Now once the tension is applied, then the piston on the other side moves back this the other anchorage block and places it against the bearing plate, and the wedges are appropriately seated in the anchorage block, and then this extra amount of the strands are cut. Another device that we may need in the post tensioning operation are the couplers. the couplers are used to connect strands or bars. They are located at the junction of the members. Usually we avoid couplers within the member itself, but when the post-tensioning operation is done for a continuous system, like in a continuous beam or in a slab, at that time the couplers are located at the junction of the members. Usually for slabs they are located near the columns, or they are located in the piers for post-tension bridge beams. Now, the couplers are also industrial products. They are tested to transmit the full capacity of the strands or the bars. A few patented examples of the couplers will now be shown. The couplers also act on the principle of wedge action. There will be the ducts from the two sides are attached. The tendons are passed through these ducts, and in one end there is a wedge system, on the other end also there is a wedge system. That means the strands from both the ends are held in place by wedge action inside the coupler, and then all these devices are inside a sleeve which can be filled up with grout once the tendons are coupled together. Each type of coupler are tested so that the strands attain their strength before the coupler fails. This is another photograph where you can clearly see that the strands from the two sides are coupled together at this junction. Now, both the strands from the two sides are subjected to wedge action. Each individual strand is sitting in a wedge unit, and like that they are held in position by the coupler. Now, these pipes are the grout tubes that once the coupling is done, then grout is passed through to fill up this annular space in the coupler, and so that there will not be corrosion for the tendons. This is another angle of the unit, and here also you can clearly see that there are two sets of wedges which hold the tendons from the two sides in place within the coupler. In one side, the outer sheath has been removed to show the anchoring of the strands, and on the other side also you can see how the two sets of strands have been coupled together, one inside them, and each set of strands is being held in place by the principle of wedge action. As I mentioned before, that there can be several patented types of couplers. Here this is another type of coupler where the individual strands are coupled together. Instead of the whole group being coupled at one location, the individual strands are coupled at different location. Here the coupling of the individual strands are staggered. Say 1/3 of the strands is coupled at one location, next with an offset there is another third is being coupled, and again there is an offset of the coupling of the rest third of the strands. That means in this whole unit the coupling of the individual strands has been offset. It makes sure that there is no weak point at the location of the coupling of the strands. Again, once the coupling is done, then grout is pumped through one side, which fills up the annular space, and the excess amount of grout gets pumped out from the other side. Another important device which we need for a post-tensioning operation is the grouting operation. The grouting can be defined as filling a duct with a material that provides anti-corrosive alkaline environment to the prestressing steel and also a strong bond between the tendon and the surrounding concrete. If we design a beam as a grouted post-tension beam, then we assume strain compatibility between the prestressing tendons and the concrete. In order to ensure this throughout the service life of the prestressed member, the quality of the grout and the quality of the grouting operation both have to be good to ensure proper bond between the steel and the concrete throughout the length of the prestressing member. The major part of the grout comprises of water and cement with a water to cement ratio of about 0.5, and in addition to that there can be some water reducing admixtures, there can be some expansive agents or pozzolans. Now, the properties of grout will be covered in the material in the module of material properties, and there we shall see that the code IS 1343 provides some specifications for the grout, so that the grout provides an anti-corrosive environment for the tendons, and then it also should not shrink too much, because if it shrinks, then again the bond between the concrete and the steel will be disrupted. That means it should not shrink, it should provide a proper anti-corrosive environment, and the grout itself should be strong enough, should have a minimum strength to sustain the prestress, the transfer of the prestress. Now, this equipment shows a grouting equipment. It is, the drum is similar to a concrete mixer that we see in most of the construction sites. In this mixing unit, water and cement and any other admixtures like water reducing admixture or expansive agents or the pozzolans, they can be mixed, and after the proper mixing, the pump will push the grout material through the tube, and this tube is attached to the grout hole in the bearing plate of the anchorage block, and through that the grout is pushed till it fills the complete annular space between the steel and the duct, and till the full space is filled up with the grout. This is ensured by the movement of the excess amount of grout to the other end, and as you had seen earlier, there are vent tubes for the escape of air, and there can be drain pipes for the escape of the excess amount of the water. Again, as I said, that the grouting operation is very important to ensure that there is a proper bond between the prestressing steel and the grout and the concrete, so that there will be a stress transfer from the prestressing steel to the concrete. Another important feature of the post-tensioning operation is that during the post-tensioning operation itself, that is the highest amount of stress that the tendons are subjected to during the post-tensioning operation. That means the quality of the concrete near the anchorage block has to be extremely good, because the end blocks are subjected to high stresses, and that is why unless the concrete is able to sustain the high stresses during the post-tensioning operation, the post-tensioning will not be successful. In a way, during the post-tensioning operation, that itself is a testing time for the anchorage block and for the concrete behind the anchorage block. Now, the designing of the end block for post-tensioning operation, we shall again come back when we look into the design of the special reinforcement that is provided in the end block of the concrete to resist the effect of the concentrated stresses. Thus, in this lecture, we covered the systems and devices for the post-tensioning operation. Post-tensioning is the type of prestressing where the tendon is tensioned after the hardening of the concrete. The important stages of post tensioning is that the first, the concrete is cast with a duct inside it. The duct can have a curved profile depending on the moment the member will be subjected to during its service life. The duct should be free of any debris, and also it should not get bent too much so that there will be difficulty in passing the tendon later on. Now, once the concrete is cast, cured and hardened to the desired strength, the tendon is passed through the duct and then it is anchored at one end. The jack is placed on the other end and the tension is applied. Once the tension is applied, the double acting jack helps to place the anchorage block and the wedges on the concrete. The excess amount of the tendon is cut off and the jacks is removed. For grouted post tension beams, grout is pumped through one end of the beam till the grout fills up the full annular space between the prestressing tendon and the duct, and it is ensured by having excess amount of grout escaping through the other end. The advantages of post tensioning as compared to pre-tensioning are: the post tensioning is suitable for heavy bulky sections, especially if we do not have equipments to transport the heavy members, and if we have to cast the members at site, then the post tensioning can be used to pre-stress the member. Of course, post tensioning can be also used for precast members where the members are made in a controlled environment, and then we of course need some transportation device to transport the member from the precasting yard to the site. Another advantage of post tensioning is that it does not depend on the transmission length for the transfer of pre-stress. The transfer of pre-stress in a post tension member mostly occurs by the anchorage blocks. Hence, the design of the anchorage blocks and the design of the end block in the concrete adjacent to the anchorage block is important, but we do not solely rely on the bond between the pre-stressing steel and the tendon and the concrete as we do for the pre-tension members. The disadvantages of post tensioning system as compared to pre-tensioning is that for post tensioning we need additional anchorage devices which are much more involved than pre-tension members, and also we need some grouting equipment for the bonded post tensioning system. Now, transporting these equipments, transporting the jacks can be difficult if the post tensioning operation is done in a remote site. Now, the devices that we need for a post tensioning operation is an ordinary casting bed, the shuttering, a duct, then we need the anchorage device, we need the jacks, we may also need couplers if we are post tensioning continuous systems, and we may also need the grouting equipment if we are preferring a grouted post tension system. Now, the sequence of anchoring is extremely important, that first the tendons are passed through the duct, then on one side one anchorage block is placed, on the other side a set of anchorage block and the jacks is placed. The jacks are usually double acting jacks, which means the pistons can move in either direction. Now, once we place the tendons through the jack, another anchorage block is placed at the end of the jack. First, the piston moves outside the member, which helps to apply tension in the tendons. Next, the other piston moves inwards, which ensures the sitting of the wedges and the anchorage blocks in the concrete, and then the extra amount of tendons is cut and the jacks are removed. The jacking operation itself is a difficult operation, and it is a testing time for the quality of the concrete and the anchorage block. Extreme care has to be taken when high prestressing force are applied to heavy members, because unless the concrete is of good quality, if there are any honeycombs in the concrete, then the end block will not be adequate, the anchorage will not be satisfactory. Hence, extreme care is required during this post-tensioning operation. The jacks have to be of high strength jacks, because most of the post-tensioning operation involves high prestressing force. Double acting jacks are preferred because it is convenient to place the anchorage blocks back into the prestressed member. If we are prestressing continuous systems, then we need couplers like say flat plates in buildings or continuous bridge decks. There we need couplers to join the strands. We had seen different types of patented couplers. In one type we have seen all the strands from the two sides have been anchored at one location. Again, the couplers use the principle of wedge action. The coupler, the whole unit is placed within a shell. Once the coupling is done, then it is filled up with grout to check any corrosion. There can be other types of couplers where all the strands are not coupled at one location. The coupling of the individual strands are staggered so that to avoid any weak location. But the couplers have to be tested before they are used for a specific purpose. Even the anchorage devices are also tested to check their strength and to check their performance under time varying load. To check their fatigue characteristics is also important when these anchorage devices are used for bridge decks. Another equipment we have learned is about the grouting equipment. Grouting is an important stage of post tensioning, where we ensure that the grout is of good quality. It will provide an anti-corrosive environment so that it will check any sort of corrosion of the prestressing tendons. Also, the grout will be strong enough to transfer the prestress between the tendon and the concrete. The grout should be strong throughout the service life of the prestressing tendon. To summarize, today we covered post tensioning. We saw the stages, the advantages and disadvantages of post tensioning. We covered the devices of post tensioning. We learned the anchorage devices, the sequence of anchoring, the jacks, the couplers and the grouting equipments. Thank you.